Hi, this is Chris Sparrow from Liquid Metrics. Today we're going to take a look at VWAP performance attribution. So let's take a look at this screen. What I've done here is I've loaded up one particular order, and this order is executed throughout the day, so it's about a 6.5 hour order. Now if we take a look at this chart right here, what this chart is showing is the fraction of volume that trades as a function of price. So that means if we fit a normal curve to this distribution, the peak of this normal curve is going to be our volume weighted average price. The width of this distribution, which we can measure using the standard deviation, we can interpret as an intraday volatility. Now why might we want to do that? Well, it turns out that different stocks have different characteristics, and some stocks have a lot of volatility and some stocks have very low volatility. And what we want to do really is handicap the difficulty of a VWAP order. Okay, and we can do that by normalizing by the intraday volatility. So that's the width of this distribution. So let's focus on this distribution a little bit more. As I said earlier, this distribution is the fraction of volume that occurs as a function of price during the lifetime of the order. And that means that this is really the opportunity set that a trader or an algo would have in interacting with the market. Okay, so this is real volume that occurred, and what we're doing is we're just mapping that. And what we can do is we can actually compare that with the volume that our order got. So if I turn that series on, we can take a look at it. And what we see is, well, these two distributions are similar. Here's our order fraction of a volume as a function of price. We do see little differences. And in this case, we're a buyer, so down here at this price, we actually see that we traded a little bit more on a relative basis than the market. So the percentage of our order at that particular price, which is $12.51, was a little bit higher for our order than the market, and that's a good thing. But then over here at $12.69, we traded a reasonable amount more, and that's not a good thing. So we could do that for every bar, and we could add it up, and we can see where our underperformance comes from. Okay. So if we turn off the market and just fit a Gaussian here, the peak is going to be actually the average price of our order. So turn that off for a second. The next thing that we can do with this chart, the price versus volume, is we can take our order volume and we can start attributing that from left to right. So at these low prices, the question we want to ask is, given the size of our order, which in this case is 12,500 shares, what's the lowest average price that we could have achieved given this market volume? And so what we do is we integrate from left to right until we use up all of the order volume, and then we can compute the average price of that. Once we do that, we're going to make that the lower end of our range. Okay, so in this case, the minimum, 12.4866, that's the lowest price anybody could have achieved executing 12,500 shares during this time period. Well, we do the same thing coming the other way, and we get our maximum price. That's 12.7445. That's this point on the dial. It's our range now on this dial spans from the lowest price we could have got given the size of our order to the highest price we could have got. What are the needles? Well, the red needle is going to be the VWAP, so it's going to be this point right here, 12.6331 is the exact number, so this is just a fit to that data. And the blue needle is our average price, and we can see our average price was a little bit higher than the VWAP, and we can take a look at this chart to try to understand why. Okay, a little bit more volume here and here. Did well in these cases, but net the difference here is explained by looking at the different prices in this volume price chart. The other thing that I can mention here, if we just go back to the market normal distribution, one standard deviation plus or minus one standard deviation would be around this width, and that corresponds to the green part of the dial here. Okay, what's the next thing that we can do? So often what's going to happen with a VWAP algo is the VWAP algo is going to hope to match the volume profile in time with what gets done with the order. So I'm going to turn off a couple of these series for a second, and we can see this is the market volume in half-hour increments using GMT over the lifetime of this particular order. So you can see we're spanning 5.5 hour period, roughly full trading day, a little bit less. And what we can see is the fraction of volume here, as well as what was the average price we got within that particular volume bin. Well, the average price, or in this case the market VWAP, is going to be the dot product, which means take this number, multiply it by that number, add it to this number times that number. Do that for all of the half-hour bins. We sum that up, and that's going to give us our volume-weighted average price. Okay. We can do the same thing with the order. Let's turn that off. This chart here, this line chart, shows us what our average price was for the order in each of these time bins, and then the bar charts is showing our fraction of volume. So what if we want to ask the question, how much of the performance deviation that I see up here is caused by me or my algo not matching the market distribution? Well, what we can do is, instead of computing the dot product of these two time series, the line and the bar, we'll swap the bar chart and we'll use the market volume instead. So what this is saying, this is the average price. If we multiply, we take the dot product, the number is actually over here. If we had matched the volume profile that we saw in the market exactly, and we multiplied it by the average prices we got within each of these 30-minute bins, we would have got an average price of this, 12.6298. The difference between that and our benchmark, 12.6331, that's going to be the deviation that is as a result of us not matching the market volume profile. Okay, we can come at it another way and say, we like the order volume profile that we got, but what if within each of the bins we match the market VWAP? We can now take the dot product of this, and that's going to give us a value here. And we can see that this one is actually very, very close to the VWAP benchmark, only differing by 1 mil. Okay, so now we have a procedure where we can attribute our performance, and not only that, we can handicap the difficulty of our performance by normalizing by the standard deviation of this market distribution here, which we interpret to be the intraday volatility. I'll put up another post very soon that describes the calculation for the intraday volatility in a little bit more detail. Hope you like this video, and please give me feedback. You can find my contact details below in the link. Thank you.